Hey everyone, and welcome. Today, we are going to tackle a brain teaser that's a true classic. You hear about it in job interviews, in logic classes, it's everywhere. It's a really cool exercise in thinking efficiently, not just fast. So get ready, let's dive into the 25 horses problem. So, here's the setup. You've got 25 beautiful, fast horses, and your job is to figure out which three are the absolute fastest. Sounds simple enough, right? But there's a huge catch. You don't have a stopwatch. You have no way of timing them. All you can do is race them and see who finishes first, second, third, and so on. Okay, so let's get the ground rules straight. We've got 25 horses in total, but our racetrack, it only has 5 lanes. That means we can only race 5 horses at a time. And here's the real kicker. All we learn from a race is the ranking. Who beat who? No times, no splits, nothing. And the goal is crystal clear. Find the top 3 fastest horses using the fewest races possible. All right, let's get into it. With a problem like this, the best place to start is almost always the most obvious, straightforward step you can take. We've got 25 horses, we can race 5 at a time, so what's the first thing we're going to do? Well, we got to race them. So the first logical step is to just get a baseline. We split our 25 horses into 5 groups of 5, we'll call them A, B, C, D, and E, and we run 5 initial races. Now, what this gives us is a ranking, but only within each group. So we know A1 is faster than A2, and B1 is faster than B2, and so on. But, and this is a big but, we have no idea if A1 is faster than B1. After 5 races, we've got 5 winners, but no real overall picture yet. Right, so now we've got our 5 winners, A1, B1, C1, D1, and E1. And it's so tempting to just assume, hey, these must be the 5 fastest horses overall. But are they? What if, say, the slowest horse in Group A is actually faster than the winning horse from Group E? We just don't know. These first 5 races only tell us about the horses inside their own little bubble. We have no clue how the groups stack up against each other. So, what's the next logical move? Well, we've got to figure out which of these groups is the fastest. And how do we do that? You guessed it. We hold a 6th race, a race of champions. We take the winner from each of those first 5 races and we pit them against each other. This race, right here, is the key that's going to unlock this whole puzzle. So, for the sake of the puzzle, let's just say these are the results from our big winners race. A1 comes in first, B1 second, C1 third, and so on. This single race gives us something incredibly valuable, a hierarchy. We now know that Group A's winner is the fastest, followed by B's winner, then C's. And this ranking, this is the foundation for our most powerful tool, pure, simple logic. Okay, this is where things get really, really cool. This is where the puzzle stops being about running and starts being about thinking. The results of this 6th race don't just tell us who's fast. They tell us who can't possibly be in the top 3. We are about to eliminate a massive chunk of the competition without even stepping back on the track. This is where the magic happens. So first things first, we can, with 100% certainty, crown our champion. The horse A1 is, without a doubt, the fastest horse of all 25. How do we know that? Well, it just beat the winners of every other group. And if it's faster than the fastest horses from those other groups, it has to be faster than all the horses in those groups. It's unbeatable. 1 down, 2 to go. And now, this right here is the absolute key to solving this thing efficiently. Listen close to this. We are looking for the top 3 fastest horses. We now know that C1 finished 3rd among the winners. Think about that. Logically, any horse that is slower than C1 has 0 chance of being in the overall top 3. Why? Because we already know of at least 3 horses that are faster, A1, B1, and C1 themselves. This one little insight is about to blow this whole problem wide open. So let's put that logic to work. Take a look at D1. It came in 4th in that race, which means it's slower than C1. Well, if the fastest horse in Group D can't make the top 3, then nobody from Group D can. They're all out. And the same thing goes for E1 and all the horses in Group E. Just like that, poof, 10 horses are completely eliminated from contention. Gone. Just look at the power of that one deduction. All of Groups D and E are out of the running. And we're not even done. What about the horses that finished 4th and 5th in Groups A, B, and C? Could they be in the overall top 3? No way. We already know of at least 3 horses faster than them in their own groups, so they're out too. Our field of 25 has just gotten a whole lot smaller. Okay, so we've got our number 1 horse, A1, locked in. The big question now is who could possibly be number 2 or number 3? Let's take a look at who's left on the board and think logically. Who are the real contenders for those last 2 spots? So let's break it down. Who's actually still in the game? From our fastest group, Group A, we have A2 and A3. The only horse they lost to was our champion, A1, so they're definitely still in the running. From Group B, we've got the winner, B1, and the runner-up, B2. B1 is obviously a contender, and B2 could potentially be faster than C1. And finally, from Group C, we have the winner, C1. We know it can't be faster than A1 or B1, but it could still snag that 3rd spot. And that's it. We're down to just 5 horses. Okay, so get this. We've taken 25 horses and, just by using pure logic, we have whittled the list down to a final group of 5 contenders for the last 2 spots on the podium. And what do you do when you have 5 horses that you need to rank? You race them. That's right, we just need one more race to solve this whole thing. This is it, the grand finale, the 7th and final race. The lineup is A2, A3, B1, B2, and C1. Through our chain of logic, these are the only horses left that have any mathematical possibility of being 2nd or 3rd fastest overall, besides our champion, A1. We run this one last race, and whoever comes in 1st and 2nd, well, those are our 2nd and 3rd fastest horses overall. And just like that, using a smart combination of racing and some serious brain power, the problem is solved. So when all is said and done, what's the magic number? The absolute minimum number of races required to solve this puzzle? 7. Not 8, not 10, but 7. It's all about using logic to make every single race count. So let's just recap that whole elegant process. Step 1 was the first 5 races, the heats, just to see who was who in their own groups. Step 2 was the big one, the winner's race, to figure out the hierarchy and, hey, crown our champion. And step 3 was the final race, with our carefully selected contenders to lock in 2nd and 3rd place. And you know, that really is the big takeaway here. The best solution wasn't just about racing over and over again. It was about thinking. Each race gave us a new piece of information, and we used that information to make the next race more meaningful, eliminating possibilities until the answer was the only thing left. This whole process is just a beautiful example of thinking smart. But the logic doesn't have to stop here. Now that you understand the principles of grouping, hierarchies, and elimination, I'll leave you with a challenge. Could you adapt this method to find the top 4 fastest horses from a field of 36 on a 6-rein track? Something to chew on. Thanks for tuning in.